Thanks for joining us today. My name is Michael Konig. I'm the Chief Business Officer at Motivo Engineering, but we work a lot in hardware-based projects in what we call HardTech. And so we thought it'd be cool to bring a diverse group of people that develop products in hardware and kind of hear their insights and some of the challenges and how to overcome them in developing HardTech, how you iterate as you go through for sure. And so oftentimes we hear about hardware-based development is expensive and takes too long, and it's not where the funding is. And so we want to kind of talk about some of the things that we have seen, our experiences, how we've overcome those obstacles, and kind of give some perspective on there are still people out there doing a ton of hardware, as you can see from this entire show. So really excited to have this group here. I'm going to let them kind of introduce themselves as they go through, because they'll be able to give you better detail than I can. Yep. So let's start with Ian.
Yep. My name's Ian Lehn. I have a few different companies in the industry that are different segments of the automotive aftermarket. Boostane, we make race fuel, which is not exactly a hard part. But then another company, Forged Authority Off-Grid, where we specialize in sustainable off-grid solutions, wind turbines, solar integration, things like that for your overlanding setup. So got a lot of product development on that side.
Hi everybody, I'm Kevin Damoa. I'm the founder and CEO of GLID. We're the world's first autonomous road-to-rail solution. That vehicle that you see over there, where those crates are, it's called Raiden. So Raiden is our autonomous version. We have a human-operated version as well that's coming out in about 2 weeks and deploying out in Kansas. But essentially has the ability to pick up a fully loaded 20-foot container, put it on the back of itself, drive over to the railroad tracks, and drive on the railroad tracks as well. So it's a truck, train, forklift, all built into one. And we service both commercial as well as defense. My background, I'm a retired military, active duty Army, 2 years in Iraq, 1 Afghanistan, firefighter in California. And I'm the first person in the world to commercially ship, launch, and recover a rocket at SpaceX. I develop all the shipping apparatus that they currently utilize to transport the rocket. So that's me. Thank you.
And you got an applause right there. That was perfect.
Thank you. Yes. Thank you.
Damon Pipenberg. I'm the Chief Technology Officer also at Motivo, along with Michael. Been there for the past 15 years, kind of done everything from being an electrical engineer to doing system stuff, to doing project management, now lead up the engineering team. But been in the automotive industry quite a while. Worked at GM, worked at Millen Works, which was Rod Millen's motorsports company for a while. Started off in Formula SAE in college, so shout out to Dean, huge advocate of Formula SAE for teaching new engineers. But yeah, over the years at Motivo, I've probably done hundreds of new product developments, and yeah, excited to share what I've learned over the years.
No, perfect. Thanks everyone for joining us today. So let's jump right into it. Each of you have been in some kind of project that's hardware-based or hard-tech-based. From developing new products or stand up entire ventures that are associated in each of those. Can each of you kind of list a project where it challenged your assumptions you've had about developing hardware and how you kind of overcame those assumptions and, you know, that new information you had?
Me? I can go, yeah. Absolutely. So when I first joined SpaceX, the way that the industry traditionally transported a rocket was via rail. What Elon wanted to do was transport it via road. So if you look at Falcon 9, the way it is, its form factor is different. You know, a traditional rocket's circumference is about 20 foot in circumference, where the Falcon 9 circumference is 14 feet. And that's to get underneath bridges. So his deal was to move it from California to each one of its test sites to its launch sites, whether it's Texas, test site, Brownsville, launch site, Cape Canaveral launch site, as well as Vandenberg. But the apparatus had to attenuate, you know, this rocket that was the thickness of it was thinner than a Coca-Cola can, right? So keep it pressurized, keep it attenuated, means balance it out on the road, and keep it dynamic enough where you don't break a 74-foot, you know, rocket. That's your engineering requirements, right? The next step is, how do you design something that is roadworthy, right? That conforms with 49 CFR. And then how do you design something that involves emerging technologies? Those are a 3-step problem. So going to the drawing boards, looking at an industrial design, applying customer requirements, and then making it a reality and deploying it out so it executes at the same exact time. How do you do it? You do it with a team. You do it with a lot of time. You do it with a lot of testing, and then you deploy it out. So, yeah.
We Forge Authority being in the overlanding space, we try to promote our customers to be able to go off grid and stay off grid. And as somebody who's an advocate, a pretty regular overlander myself, going out for long periods of time, I like to have some of my amenities along with me, but I don't want to hear a Honda generator running in the background. It kind of ruins the ambiance of trying to camp out in the woods. But where I'm from, we don't get a lot of sunlight. It's not Seattle. I live in Ohio, in the Ohio Valley and all that stuff. We don't get any sun, but we get a ton of wind. And I really wanted to try to come up with a solution that utilized wind energy to be able to generate power for our campsite and all of the equipment, from Starlink to everything else that we wanted to run at the campsite. And we really had to try to figure out how do you create a wind turbine that has a form factor large enough to be able to sustain different electrical systems, but is also transportable, is able to go off-road, able to go over rocks, things like that, and then deploy very easily without taking up, a lot of different space. And by kind of breaking each of those variables down, it helped us define Dorothy and what she ended up kind of going to market with. Is really kind of how we landed on one of our most recent iterations, is kind of looking at each variable of the equation and kind of solving for each one of those individually to kind of allow you to create an overall picture.
So kind of like break it down to its parts.
Break it down
Focus
to
on
its
the
parts.
parts, then bring it all together.
Eat the whale one bite at a time.
Yeah, so at Motivo, about 10 years ago, we had a client who wanted to know, could you kind of change the way cars are manufactured? Typical car, you have sheets of steel and casting and all these different methods that you can make cars very cheaply in huge volumes, but it takes a huge amount of effort to make a new car. So they had this idea, well, can we use 3D printing or additive manufacturing to do that? And we built them a prototype, a supercar. The chassis was all 3D printed. At the time, that process, like additive manufacturing of metal, was brand new. It wasn't that great. You'd get parts out and they'd have holes and cracks in them, and we worked through that process and tested everything out and got to the point where we had a prototype. And now they are a big company, have that car going into production. It's winning, I think it won the lap record at Laguna Seca recently. So it's been, a pretty rewarding experience to see that technology go from something that no one believed would actually work to being a real car and being used in a production car, being used in aerospace applications, being used in defense applications. So that's been a fun one.
No, all great examples. Each of you kind of more or less talked about like prototyping and getting through there in hardware. So when developing hardware is so resource intensive and so time consuming and financially consuming, how do you kind of go through that prototyping process and decide what good enough looks like to actually go through your iterations?
I think the world has changed a lot lately. Prototyping has a completely new definition nowadays. I mean, I can come up with an idea and, have it 3D printed by lunch kind of thing. And that's been it's been a new resource that you've kind of had to put in your toolbox. I think it's really, I forget, I think it was like General Patton that said, a good plan executed today is better than a perfect plan executed tomorrow. I've always loved kind of rapid prototyping, failing, and going back to the drawing board, other than, you can kind of stare at a piece of paper or a drawing for a really long time and think about all the different ways that it'll work or not work, but until you kind of put it out into the physical world and break it, You really don't know. And I would say that from a prototyping standpoint, if you can arrive at a good enough idea that it's like, hey, let's send it to prototyping and learn as much as we can from it. Let's do it now. As long as it's in your budget. Obviously, small businesses, startups, things like that, that's going to dictate a lot of it. But put it out there and break it early.
Yeah, for me, I think it's partnering with folks, right? You don't build beautiful cars all by yourself. You partner with great folks and you integrate a technology that is proven that comes with certification, and then you identify what your secret sauce is. Your secret sauce could be, like Raiden, for example, that's sitting over there. We've integrated product that works, that has certification with proprietary chassis, proprietary systems, with emergent technologies in 3D printing, emergent technologies in vibe coding, for example. You're able to deploy a product that works right out of the gate, but it makes it more effective when you're able to partner with like leaders in autonomy, leaders in chassis, leaders in powertrain, to put together a system that works very, very fast and be able to scale that up, reliably. So that's what we do at GLID.
Yeah, I guess, Damon, at Motivo, we often talk about bench testing and risk reduction earlier in programs. Can you talk a little bit about the value of doing that, especially when you're developing hardware?
Yeah, for sure. So I think the big thing is when you go, think about developing a new product. You might start out on a whiteboard and you go into the computer and you do CAD work. You might make a first prototype. Each one of those steps, as you go further and further into that development process, it is harder to change things. So if you're doing it on a whiteboard, super easy to X something out and change it. If you're doing it in CAD, it might take a little bit more time. If it's the first prototype, you can still do stuff. You can grind stuff, you can weld stuff. Once you get to hundreds or thousands, it becomes more and more cost prohibitive to change anything. So at Motivo, we heavily advocate for test things early and often. Try things out, break them. We want things to break, see what breaks, then we can make a change and fix it before it becomes too difficult to make that change.
No, that's a great segue to talking about scaling your prototypes to manufacturing. Manufacturing on hardware in itself is its own design cycle. You have to figure out what your line looks like, what your manufacturing process is, what your tooling looks like. A lot of the trends nowadays in software development are associated with being able to do over-the-air updates. So you can actually push software product out faster, actually use your end customer as your test bench, get the feedback, and then iterate. It's a lot harder to do that with hardware because of things like recalls and warranties and retrofits. So as you go into those considerations, how do you think about that process as preventing that from happening further down the line? Or can anybody give us an example where you realize as you went into it that this design actually isn't manufacturable? What do we do now?
Yeah, so I think especially with emergent technologies, you look at mixed mediums from a manufacturing perspective, right? Classical manufacturing is you utilize box tube or traditional sheet metal, and you give it to a tooling shop. New method is you 3D print it, utilizing several different mediums in order to identify form, fit, and function within the factor of your design. Where you can pull out, break, and put back in, utilizing whatever medium you want, whether it's polymer or different types of metal. I mean, you can even 3D print titanium now, within a mesh. So that's changed, and then you incorporate that with your traditional, box tube chassis as well, or you can 3D print chassis. So, I think that emergent technologies has supported that quite a bit.
I think you can do everything you can in the design process, in the prototyping and all that to kind of crystal ball and try to hope to understand what's coming down the pipeline and design for. It shouldn't be something that gives anybody paralysis about it. I mean, ultimately technologies change and products evolve and develop. Inevitably there's going to be things that become outdated. We always try to, understand that eventually our product is going to be presented with new emerging technology. That we want to be able to try to design around having the opportunity to accept those new technologies and implement them into kind of our current platform, whether it be our wind turbine system or our truck bed system or power sports, because we know that it's inevitably going to happen. Like every year there's new technologies, and if you design yourself into kind of a pigeonhole where you can't adapt, now the whole product, the chance of being kind of obsolete. So you just don't want to kind of obsolete yourself, but it shouldn't cause paralysis either when you're in the design process.
What do you all generally see as the biggest gap between engineering optimism and production reality?
The optimism is we can solve anything.
Totally.
We can solve, I'll engineer, anybody. No, I think the tough part is, a lot of the companies here are pretty small, so everybody wears pretty different hats. I mean, you wear a ton of hats. I mean, Motivo, we all get to work on different stuff, and sometimes we're working on accounting, sometimes we're working on manufacturing, engineering. I think it's good to have that perspective, because ultimately when you are designing things, if you keep your head kind of too far in the sand, you'll pull up and realize that it's going to be impossible to make that part. So kind of maintaining that 30,000 foot view when you're going through the process is invaluable to make sure that at the end of the day, you've got something that'll actually bring ROI.
And I guess the other side is making sure you're not designing unobtainium, right? So you're designing things that actually can, you can pay for, or what's in your bank account, or what you can raise, is a big thing. I know I draw a lot on my SpaceX days, because we dreamt about going to Mars, right? That's a mission that costs billions, if not trillions of dollars in order to accomplish that. But how do you do that and take bite-sized steps towards that, right? And that's by designing something that you can pay for, over time, and skip step, ways in order to get there, within your means. So you see a lot of startups die because they design these ultra futuristic things that for one doesn't serve a big purpose, and for two are designed in a vacuum, right? So when you're a CEO that wears multiple hats, you know that you focus your engineering team on aligning with your procurement team that aligns with your financial team to put product out that actually brings in revenue. So, yeah.
How many panelists draw their experience from a mission to Mars at
Not a
the
lot.
SEMA show? I've never been on a panel where that's pretty cool.
Well, let's talk about building teams, right? Building teams that build things is what we're talking about, especially on the hardware based. So often hardware development can take weeks, months, years on certain platforms, right? So how do each of you manage keeping your teams motivated through that process where they hit walls and they have to overcome challenges and they have to throw away things they've actually put their hands on to keep it going?
You feed them free lunch. No, I'm joking. No.
Pizza for everyone.
I think it's mission, right? At the end of the day, you have to be, right? You onboard team members based on the character in which they have, and then that aligns with the mission. And the product will change, right? The product is made to evolve, but if the mission doesn't change, then they understand that their core focus is to achieve that mission. And they're able to accept, hey, I worked a year on a project, really work. Sorry, I use my big voice. That doesn't really work, and I can cascade it into something else, and that's what drives folks where we are.
Yeah, I think inevitably all teams are going to have failures, some longer than others. I was always told, you learn more from your losses than your wins. Every time we've kind of looked at a bigger project, not Mars necessarily, but every time we've been trying to tackle a bigger project, when we've come to those failures where we're just like, oh, this didn't work. Like, I've tried to kind of find the light at the end of the tunnel to say, hey, what did we kind of learn from this? And, you know, how can we, and kind of take the focus away from where that failure is, because it sucks, and try to, you know, get the motivation and take the momentum into kind of what the next iteration is going to be. It's like, all right, we figured it out. We figured it out now. It's a good thing we didn't figure this out when it was being mass produced. We figured it out right now. Let's roll it into the next iteration and let's engineer around it, you know, on the next one, and we'll be good to go. So, you know, not focusing on those things is always been a way that I've tried to keep the team, you know, motivated.
Yeah, I think Ian's spot on with that for sure. I mean, our big thing is making sure the team knows to expect that they will fail, and that's not a bad thing. If anything, it's a good thing. We'd prefer that happen earlier, so you learn things and can make the changes and fix them. If you hide potential failures and they come up later, that's really the worst scenario. So you want to see that happen. I mean, in racing, you see this all the time. You want to go out and test and test and test, break things, so when the race comes, you make it through the race.
I think that he brings up a really good point, that hiding a flaw or a failure, because you just don't want to hear you just don't want to hear the bad news. Like, sometimes you need, whether it's testing or somebody else reviewing it, you need somebody to tell you your baby's ugly sometimes. And nobody wants to tell you your baby's ugly, but sometimes you need to hear it. You know, hiding that flaw inevitably is going to be a cancer. And so sussing it out early so you can solve for it is not only going to be the best solution, but it's going to save you way more money than dealing with it when you've tooled up and all that other stuff around a subpar design.
No, that's great insight. Let's take it away from the team and make it about you all individuals then. Each of you are pretty much the top leaders of your business, right? And so you're setting vision, you're setting, you know, kind of the motivation for the team. How do each of you handle failure, especially on the hardware side, that keeps the team focused and moving forward?
Urban? No, I think you build up a callus to it, you know. Being at kind of, you know, at the top, you know, where the buck stops with you, you kind of got to dig deep sometimes and figure out, you know, that there is something at the end of this long journey that's going to be worth, you know, all of the late nights and all of the risk that you end up taking, you know. But it's, you know, now and then it's just finding the small wins, you know, hiring somebody onto your team that you kind of like, you see how excited they are to be a part of the project, and you're like, oh yeah, what we are doing is pretty cool. Like, you know, sometimes you just need that outside perspective to kind of be reinvigorated, and I look for that all the time in other people that we work with, other, you know, people like Motivo, you know, coming on a panel like this and getting to meet Kevin and talking to him and hearing his story, like, those types of things are kind of what keep me focused and motivated, finding around you.
Yeah, you know, for me, it's extreme leadership, you know, and a lot of prayer. You know, a part of this journey is incremental gains and incremental losses. You know, you measure everything by an inch, you know, and you reassess, and you just know it's a part of the game. You can't, you know, it's failure has to be in it. You know, I rather failure than big successes. You know, success is, you know, hide pain points. They're momentary, like happiness. Your quest is to be content, you know, not to be, you know, absolutely happy all the time. And, you know, running a business is just that, right? You have days where you're like, man, I didn't want to hide underneath my coverage, and you want to celebrate and scream it to the high masses. But through it all, you know, you give praise to God and family first and foremost. But, you know, me as a leader, I try my best to motivate my team based on those core competencies. You know, lead with integrity, own everything that you do. You know, give glory to God, and protect your teammate. You know, I talked about me being in war. You know, 2 tours in Iraq, 1 in Afghanistan, and you know, we always protected our person in foxhole no matter what, and that's the same principles that we run GLID by as well. So.
Yeah, I think on my side, you know, I was fortunate early on to do Formula SE in college, and for me that was an amazing experience because you could try all these different things, fail over and over and over again. It was, heartbreaking to build a race car and bring it to this competition and something breaks midway through the race, but it was an amazing learning experience and kind of build up that muscle to then go into engineering as a career and be able to realize that you want to build things and test them, and if anything, it's better to have it break early on and be able to work through it. It's like super easy, I think, as an engineer to want everything to go perfectly. Like, I'm gonna sit down and design this thing and spend hours and hours on it, and then I'm gonna build it, and it's gonna be perfect, and everything's gonna be awesome. It's just not how things work in reality. So getting to a point where you can build something and you almost hope that it breaks the first time, because then you learn something from it and can try again, is really important and something we try to instill in our team. Give them space to let them fail and try again, because that's how you get to success.
Sorry, I thought I had another slide. With this being the FutureTech studio, let's kind of look into the future a little bit. So what do each of you think the hardest hardware-based problem is going to be to overcome in the next 5 years?
As if you're developing products, and I was talking about the 30,000 foot view, and you kind of got to wear different hats, and you got to make sure that there's kind of ROI at the end of the, journey. Something that I think, and whether it's going to be a threat or an opportunity, I think there's going to be a lot of external factors from, different types of trade, tariffs and other things like that. And I know there's other panels that are going to be talking about that, but trying to design a little bit with that in mind, knowing that the future is is not written, it's unsure. So kind of trying to future-proof your designs, knowing that you're not designing only for unobtainium or one particular component, knowing that you might have to adapt because there's going to be legislation or regulation or something else, an external factor outside of our control, that we just got to be ready to pivot on, is something that I always keep in the kind of back of my mind.
Yeah, and I think you go back on his point. It's always external items that come in. I mean, we have the ability to build, right? We have all this custom stuff. A lot of the stuff is one-off, though, right? America is facing this reindustrialization right now, where we lost a lot of our abilities to actually scale and build, and the jobs that were once sexy 60 years ago aren't sexy anymore, and they need to be sexy in logistics and manufacturing and warehousing. So I think that as an American people, we have to be able to take those jobs again, and at the same time work hand in hand with robotics in order to make it happen. I don't think that robotics should take over a human's job, but I feel that we should do it smartly together. So that's a big hump that we have to go over, outside of like tariffs and everything that happened outside of this country. But the thing control is reintroduce that institutional knowledge of how do you build better as Americans. So that's how I see it.
Yeah, I think the trade external factors are certainly one of the biggest things we've been seeing at Motivo across a lot of our projects and clients. The other one I'd probably add on would be like AI and robotics. Things are changing very, very quickly right now. I think there's a lot of hype out there. I could not predict what effect all that will have on our industry in 5 years. It's almost impossible at this point. But for me, it is trying to keep up with that, see what actually works, see what is just like total hype and is useless, and picking out the things that work and staying ahead of the competition, because when things are changing really quickly, that is one of the big challenges, is staying ahead of everyone else.
It's an opportunity. Ultimately, I think the future is an opportunity, because a lot of those external challenges, if you could stay ahead of the competition, is a way for you to take is gain an advantage. over what's happening.
No, that's great insight. And so I guess as we wrap up our time, what's the one piece of advice you'd give somebody in the audience if they were trying to start a hardware-based project or company?
Yeah, I find the problem, right? I think that's the biggest thing. Find the problem that is actually a problem, and solve that, right? Don't join the hype cycles, right? There's a lot of folks building product that doesn't serve a purpose, and it wastes a lot of people's time and money and on all sides. But find a problem that serves your community. I talk a lot about paying rent, right? We pay rent for our spot here on Earth, and everything here is temporary. So how do you pay rent for your neighbor, right? It's by creating something that is going to be long lasting for generations to come. That's real generational wealth. So that's what I'll leave folks with. Pay rent. Let's glide.
That's awesome. It's a tough one to follow up. Off that. I think it's if you are going to solve that problem, finding that problem obviously is an opportunity, and if you identify it, awesome. Try to find passion in it, and in what you kind of really love to do, because there are going to be those failures and those really dark times, whether it's money or stuff not working or anything else like that, and sometimes that's what you gotta lean back on to kind of get you through it. So find something that you're passionate about.
Yeah, I think that's great. I'll just keep it simple. I'd say, find things you're interested in, build stuff, break it, get your friends, customers to break it, as they will figure out stuff that you'd never figure out yourself, and hopefully enjoy the process.
No, thank you. And I want to thank all three of you. I get all three of your insights all the time, and it's great to share with the audience. And hopefully we are able to provide a little bit of information that can make hardware and hard tech a little less hard. So thank you so much.
It's our honor. Thank you.
Thanks, guys.
Thank you.